Hi everybody, we're going to do the Unit 2 Exponents and Scientific Notation Assessment Study Guide. We're going to start with question number 1. So the first question gives us a negative exponent. So I know when I have a negative exponent, I have to use the inverse of that fraction. So basically I'm flipping it upside down. Then I'm going to multiply that by 1/5 times 1/5 again. And then I have 3/8. Okay, so now I'm going to take a look at just the numerators. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And then 2 times 5 is 10, times 5 is 50, times 8 is 400, times 8 is 3,200, times 8 is 25,600. So that's going to be what it looks like simplified. The next question is giving you the quotient property, and they want you to use a single exponent to write the value. So the bases are the same. So I'm going to do 8 minus -1. And I remember that I have to keep change when I'm subtracting integers. So I have 8 plus 1. So my answer should be 5 to the 9th power. The next question says 4 to the 3rd power times 4 to the -1. So that's telling me that I have to add these because this is the product property. So 3 plus -1. So I end up with 4 to the 2nd power. They want us to circle all the true statements. So all the true statements I have to circle. So I know that I would add these because that's the product property, and I should get 1. So that's not true. -2, so -2 plus 5, that's going to give me a +3. So this one's true. I have 6 plus 0 plus -1. So that's going to give me a 5. So that's not true. Anytime you have a negative exponent, it pushes the value into the denominator, or basically it changes the fraction. So it causes it to be the inverse. So this one is true. And then for here, we have the quotient property. So I have x is 8 minus 2, which would be 6. So this one's not true. All right, use a single exponent to write the value of the expression. So I've got x and then x. So my bases are the same. So I'm going to do 6 plus 5, x equal, x to the 11th. All right, which expression is equal to 4 squared? So I know 4 squared means 4 times 4, which is 16. So 16 to the 0 power, anything to the 0 power is 1. So this one, I'm going to be adding 4 and then 3 plus 5. So that's 4 to the 8th power. So that's definitely not going to work. This is power of a power. So I'm going to do 4 and then -1 times -2. So a negative times a negative is a positive. So I get 4 squared. That looks promising. And then my last one's quotient. So I'm doing 4 minus -2. Keep change. 4 plus 2, I get 6. So that is my equivalent. How do I write this as a power? Well, I have 1, 2, 3, 4. So I have 4 6s. So 6 to the 4th power. They want us to write any expression that is equivalent using one exponent. So I start in my parentheses, and I have the same base. So I'm doing 2 plus -4. So I end up with 3 to the -2 times -3. Now, the first part was the product property. Now I have the quotient property. So I'm going to multiply these. So negative 3 times negative 2 is positive 6. So let's just take a look and see if that works out no matter what I do. So let's distribute this. So let's say I have 3 times 2 to the negative third power. So that gives me 3 to the negative 6. And then I have times 3 negative 4. Oops. And then negative 4 times negative 3 gives me positive 12. So again, I would add my exponents. Negative 6 plus 12 is going to give me positive 6. So no matter which way I did it, it was going to work out because the bases are the same. All right, write an expression that is equivalent using only one exponent. Well, I know that 5 to the first power, negative 2. So that's going to give me 5 to the negative 1 times 0. Anything to the 0 power is 1. All right, which number best represents the number of liters in a drop of sweat? Okay, drop of sweat. So I know it's not going to be a positive, so it's got to be one of the negatives. Then when I think about the number of liters, so that's a pretty big thing, a liter. So like a liter of pop, like a liter of a drink. So it's going to have to be really, really small if we're talking about the number of liters in a drop of sweat. Because you got to think a liter, you can get a liter of Coke. And then a drop of sweat is so small. Choose all the perfect squares. Well, this one's 12 times 12. This one's 8 times 8. And this one's 1 times 1. All right, which of the following numbers is rational and which one is irrational? Something's telling me that my square roots might not have come across when I did my, let me look. Yep, they didn't come across. So these are square root symbols. Okay, so I have to have a perfect square in my square root symbol to be rational. So this one's going to be my rational because the perfect, or the square root is 7. It's a perfect whole number. This one is irrational because there's no pattern. When you put in the square root of 63, it's not going to come out as anything that can be converted into a fraction or a terminating decimal. Red blood cells are usually about 9 times negative 7 meters in diameter. What is that number written in standard form? So I have my 9 and I put my decimal point. And then if I'm going in the negative exponent, that's 1, 2, 3, 4, 5, 6, 7. I put my decimal, and then I'm going to put zeros all in front. So that's what it's going to look like in standard form. They predicted sales for an opening weekend of 2 movies. According to the prediction, how many more tickets will be sold in movie Y than in movie Z? How many more? So that's telling me I've got to subtract. So I have 1.9 times 10 to the 8th, and then 6 times 10 to the 7th. And you know you have to change the exponent that's lower. So I'm going to take my decimal, move it over 1, change that to an 8. Then I'm going to subtract my 2 multipliers. So I end up with 1.3 times 10 to the 8th power. President Ronald Reagan earned a yearly salary of 3 times 10 to the 4th dollars as president. He served for 8 years. What is the total amount of money Ronald Reagan earned as president? Write your answer in scientific notation. Okay, so I know that 3 times 10 to the 4th is 1, 2, 3, 4. So he made $30,000 a year times 8. So let's see what that's going to be in my calculator. 30, 1, 2, 3. Yep, times 8. And I get 2, 4, 1, 2, 3, 4. So I have 240,000. So then I have to put my decimal back in. I'm going backwards. 1, 2, 3, 4, 5. So it's 2.4 times 10 to the 5th power. Question 16. They want us to write our answer in scientific notation. So we're dividing. So I'm going to do 7 divided by 3.5, and I get 2. Then I have to subtract my exponents. So 5 minus negative 6. Keep, change. 5 plus 6 is 11. All right, write the following number in standard form. So I have 4.5. 1, 2, 3, 4, 5. So I get 450,000. All right, they want us to multiply now. Well, I know that I'm going to multiply my multipliers. Sounds kind of silly, doesn't it? So 4.5 times 2.18, and I get 9.81. Then I'm going to add my exponents. So I multiply my multipliers and I add my exponents. So negative 4 plus 9 is positive 5. So times 10 to the 5th power. All right, they want us to subtract these. So I have 4.5 times 10 to the 9th. And then 10.35 times 10 to the negative 2. All right, so I have to change the negative 2 into ninths. So I've got to think, okay, how many jumps are we talking about? Because this is more than just what I can do in my head. Well, I can, but... Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 jumps. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's a lot of zeros in the front. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so then I subtract my multipliers. So I've got 4.5 minus 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. 9 zeros. 1, 0, 3, 5. Whew. And I get a crazy number. So I end up with 4.49 repeating times 10 to the 9th power. So technically I could round that up and make that 4.5 to the 9th power. Last question. In 2014, the United States population was 4.2 times 10 to the ninth. Population of Switzerland was about 7.5 million. About how many times larger was the population of the United States than Switzerland? All right, so 7.5 million. So I have to think, okay, well, what's a million going to look like? This is right off of our choice board. So we know that, let's think about how we should better do this. Okay. So we've got 7.5, right? That's 75, 750, 7,500, 75,000, 750,000, 7,500,000. So I added my zeros. So that's 1, 2, 3, 4, 5 zeros when we're talking about a million. So we had to add 6 hoops after the 0.5. Okay, so let's rewrite that in scientific notation. 7.5 times 10 to the 6th power. And we've got 4.2 times 10 to the 9th power. Now we've got to change this to be 9. So I'm going to move this 1, 2, 3. And we're going to subtract. Oh, wait, they want to know how many times larger, so I'm going to divide. 4.2 divided by... Hang on. I goofed this somehow. Let's try that all over again. So we know that we have 7.5 times 10 to the 6th. And we know that we have 4.2 times 10 to the 9th. Good thing I reread the problem because it says how many times larger. So I'm actually dividing these two. All right, so I'm going to do 4.2 divided by 7.5. And I get 0.56 times 10. And then I got to subtract these two exponents to the third. Now we know we can't leave it like this because we don't have a whole number in front of our exponent. So 5.6 times 10 to the second. Which works out to be 560 times the size. All right, if you have any questions, let me know. I hope you have a great rest of your day. Bye.